All right, let's tackle this problem right here, number 1 on this worksheet. All right, let's work on question number 1. All right, the first thing I'm going to do is I'm going to write my Leo and my Gur down. We're going to write the oxidation and the reduction half reactions for this problem. You'll notice that this problem has no spectators, and they've also given us the oxidation numbers. So there's the oxidation numbers right there. So all we have to do is we have to figure out which one has the oxidation number that's increasing in value and which one has the oxidation number that's decreasing in value. So I'm going to erase those lines, and I'm going to take a marker and I'm just going to connect the chromiums together. And you can see that the chromium went from a +1, let me get a pointer, +1 right there to a +3 right there. So we have chromium +1 went to a chromium +3, and the oxidation number increased. Now, it increased by 2, went from +1 to +2 to +3. So the difference between these two numbers, +1 and +3, is 2. I did not write these coefficients in, but if you did, you would have to account for them. But I didn't, so I'm going to leave them off for a second. We go from a +1 to a +3. That means each chromium is losing 2 electrons. So I'm going to put those 2 electrons on the product side, because in an oxidation half reaction, the electrons go on the right side of the arrow. All right, now I'm going to do the SN. The SN went from a +4 to an SN +2. And you can see that the SN gained 2 electrons. If I can find the pointer again, here's +4. And it gained 2 electrons to become a +2. So I'm going to put those electrons in here, +2 electrons, and we are done. Now, the question is asking what is being oxidized, what is being reduced. The chromium +1, right there, is being oxidized and turning into chromium +3. So this is a chromium +1 is being oxidized, and the tin with the +4 charge is being reduced. It's going from +4 to +2. So this is being reduced. Remember, always pick from the reactant side of your equation, which means left side of the arrow, when they're asking what's being oxidized and what's being reduced. All right, question number 2. We've got 3 mercuries. Let's pull this up. 3 mercuries with a +2 charge, +2 irons with a 0 charge. Let's write that in. Become 3 mercuries with a 0 charge, and you end up with 2 irons with a +3 charge. So we're going to write Leo and Gur. Leo and Gur. Okay, which one is increasing in oxidation number? That's going to be the iron. The iron is going from a 0 to an iron +3. Now, I'm going to put the coefficients in, not like I didn't do that on the last one, but I'm going to do it on this one so you can see that it'll work the same way. So we've got a iron going from 0 to +3. That means each iron is going from a 0 to a +3 charge, and it is losing 3 electrons. But I've got 2 irons that are doing the losing. So 2 irons, each losing 3 electrons, we lost a total of 6 electrons. Now let's do the Gur. The Gur is going to be 3 mercuries, starting as a +2 charge, and becoming 3 mercuries with a 0 charge. Okay? Now, this 2, I told you in class to just cross that off, so we won't have to worry about that. Now we're going to do how many electrons are being gained. So I just changed the color here. We started with a +2. We ended up with a 0. So each mercury is gaining 2 electrons. How many mercuries do we have that's doing the gaining? We have 3, so we're gaining a total of 6 electrons. That's the difference between these two numbers, 2 and 0 is 2, times how many mercuries I have, which is 3. 2 times 3 is 6. All right, what's being oxidized? The Fe0 is being oxidized. That's this guy. Again, pick from your reactant side. What's being reduced? The mercury with the +2 charge is being reduced. Okay, number 3. Again, starting with our Leo and our Gur. Leo, Gur. I'll put my arrows in for reference. Alright. Assign my oxidation numbers. I'll use blue. 0, 0, +3 minus 1. What's being oxidized? The AS is going from 0 to AS +3. I can put the 2's there if I want. How many electrons are being lost? The difference between the 0 and the 3 times how many AS's I have, so that's a total of 6 electrons being lost. Now we'll do the chlorines. We're going to start out with 3 chlorines with a 0 charge, and we're going to end up with 2 Cl3s with a -1 charge. Alright, again, you find the number of electrons that were gained by looking at the oxidation numbers. That's a 1 electron gain for each chlorine, but I've got 6 chlorines, so I've gained 6 electrons. What's being oxidized? The AS with the 0 charge. What's being reduced? The chlorine with the 0 charge. Alright, start. Oh, I don't like that color. That's an ugly color. Alright, Leo, Gur. Okay, oxidation numbers. Zinc is 0, +2, +2, 0. Leo is zinc 0 going to zinc +2, plus 2 electrons. Copper +2, +2 electrons going to copper 0. What's being oxidized? The zinc with the 0 charge. What's being reduced? The copper with the +2 charge. Okay, I know I'm going fast, but I want to make a shorter video. Alright, to save some time, I just wrote the oxidation numbers down for us. Let's look for the Leo. The Leo is going to be the carbon. It's going from a 0 to a carbon +4. Oops, +4. That's carbon, not copper. Okay, and we're going to keep it with 1 carbon, and we have lost 4 electrons. The sulfur went from a +6 to a +4, and we have gained 2 electrons. Okay, what's being oxidized? The carbon, I said copper again, that's carbon. Carbon with the 0 charge, and what's being reduced? The sulfur with the +6 charge. Okay, now let's do the next one. Alright, so let's find what's changing. What's going up? I didn't look before I started recording this. The N is going down. It's going from +5 to N +2. What's going up? Oh, the iodine. So iodine is -1. If you don't see it, it's right here. -1 and becoming a 0. So let's get a pen here. I is becoming I20. Okay, let's balance this for mass. There's 1 I there, pointer, 1 I there, and 2 there. So I'm going to balance that for mass first. Always check to make sure you balance for mass before you start tackling those electrons. And then I'm going to say each I is losing 1 electron, but there's 2 I's, so we're going to have it losing a total of 2 electrons. And then the nitrogen, there's only 1 on each side, so that's good. And then we're going to gain 3 electrons. Okay, so what's being oxidized? The I with the negative charge, and what's being reduced? The N with the +5 charge. Alright, the last 2. Okay, find the thing that is increasing in value, because we're looking for a Leo. So K stayed +1, Mn went down, so that's going to be my Gur. Just write that in since I found it already. It starts as a +7, ends up as an Mn +4. And then oxygen's a -2 over here, and it's going to be a -2 over there, so that's not it. Chlorine, there it is, -1, and it becomes a 0. So let's go back here and let's write chlorine with a -1 charge became chlorine with a 0 charge. Now let's tackle the electrons. Make sure we're balanced for charge, 2 chlorines on both sides of the equation. And so we're going to take The difference between these two numbers, -1 and 0, means each chlorine is losing an electron, but there's 2 chlorines, so we lost a total of 2 electrons. And then with the reduction half reaction, we have to look, there's 1 manganese, that's good. The difference is 3, so each manganese is gaining 3 electrons, plus 3 electrons. Okay, all right, last question. Let's do this fast because the bell's going to ring. All right, so just to save time, I assigned our oxidation numbers. They're up here. Okay, you can see the SB is what's being oxidized because it is increasing in its oxidation number, and the N plus 5 is what's being reduced. So we'll just write that in, N plus 5. Okay, all right, hopefully that helped.